Welcome back everyone. This is the second part of the lab 1. So let's build our next circuit. Again we need power supply and ground. So let's first get that VCC and ground. Okay. So in this again we will need a LED. Okay. This time we will see what is a slide switch. Okay, let me pick two LEDs to illustrate the behavior of a slide switch. So let me pick one to be a blue LED and other one to be a red LED. Okay, so that we can see which LED is glowing at what time. So you scroll down here, go to the plus symbol and scroll down here. You can see a slide switch. Let us pick. So you can see that the slide switch is having 3 terminals. The slide switch is having 3 terminals. So by default you can see here this black contact is not in the center. This black contact is between the position 1 and 2. When you move it this way, it is between the position 2 and 3. Correct? This is 2 and 3. So when you move this switch, the 2 will be connected to 3. If you don't move the switch, if you don't slide it, 1 is connected to 2. That's how it is. So what I'm going to do is I'm going to take the VCC and connect it to the central terminal of the switch. Okay. And this terminal of the switch I'm connecting it to the anode of LED 2. This terminal of the switch I'm connecting it to the anode of LED 1. The cathode of both the LEDs are connected to the ground. Now let's see what happens. The cathode of both the LEDs are connected to ground. Let us play and see what happens. See, as soon as I started the simulation, by default this LED is glowing. You can see this LED is glowing, correct? So this is why I call this as a normally on position. Without doing anything, this LED is on. So that is why this is called as a normally on position. This LED is off. So this is the normally off position of the switch. Now you see I am going to operate this switch. You see this moved. You see when I am clicking it, it's moving. So when it moved from here to here, this LED turns on, this LED turns off. Why? Because the contact slided. When the switch is in this position, the VCC is connected to this terminal. And from here, the current, you are having anode to cathode to ground. So VCC through switch goes to anode to cathode to ground. Current flows from high potential to low potential. Thereby LED is glowing. Whereas in this side, VCC is coming here, but from here to here the contact is broken, so no current flows to the blue LED, so the blue LED is off. When I slide the switch here, now VCC is no more connected to this terminal, so the red LED is off. VCC is connected to this terminal, so through this path the current flows. And again here, the way we are connected is such that the current flows from anode to cathode to ground. So the LED, blue LED is glowing. Fine. So again, I will stop the simulation and start it once again for you to observe. Now see, as soon as I click the play, you will see the blue LED is glowing. The blue LED is glowing because this switch position 1 and 2 are by default connected. This is the default connection of the switch. That is why this contact is called as normally closed output of the switch, or normally closed output of the switch. So, and this contact is off by default, so it is called as the normally open contact of the switch, or the NO. This is the NC contact and this is the NO contact of the switch. When you operate the switch, the NC contact is getting off and NO contact is getting on. The normally open contact gets now closed and it turns on. Okay, I hope this is clear. Okay, so I want you guys to try this out in the lab. Okay, thank you.